How dangerous would a massive solar storm be for future Moon and Mars bases? Can more exoplanet discoveries stimulate more funding? And what's the ultimate fate of galaxy clusters? And in Q&A Plus, would I go on a moon voyage? All this and more in this week's Question Show. It's time for the Question Show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Slow Boy Fuel Pump. How devastating would a Kerrington event be to our plans for the Moon and Mars? I mean, like a Kerrington event, this was this thing that happened in the 1800s that was a very powerful solar storm. You know, I always have to say that it caught the telegraph poles on fire, that you were able to see auroras close to the equator. It was a thing. And that if it happened now, like really any flare that is above 10, like an X10 flare, is once you start to get damage to the electrical grid, damage to satellites, communications blackouts on the part of the world that is facing the sun. And those happen fairly often. Every solar cycle, you get a few of these X10 flares and above. And this is not the worst that the sun can throw at us. We have seen flares that are worse than the Kerrington event. They just went in other directions. They didn't come towards us. They went off into space. But if we were on the receiving end of that flare, it would have been a very bad day. And we have had problems with flares in the past in our more modern age. Like 1989, there was this ice storm in Quebec and there was a solar flare. We had problems with the power grid in Canada. There have been other times when solar flares have caused damage on Earth. And so, like, what would that do? Well, if there was a spacecraft filled with astronauts that were on their way to Mars and they happened to get caught during something like the Kerrington event, they could receive a lethal dose of radiation in an hour. And then they would die within a day. The chances of that happening are incredibly remote, but it's not zero. And so there are preventative measures that NASA has proposed to be able to deal with this. Essentially, like for the Artemis mission, for the Orion capsule, the astronauts, if there is a powerful solar flare while they're on their way around the moon with Artemis 2, they have a bunch of supplies on board that they can use to shield themselves. Essentially, they build a fort inside the Orion capsule and they hide inside, behind all of their water and their electronics and their food and anything that can put protons between them and the solar flare. But if we have a moon base, that base will need to be shielded. If we have a base on Mars, that base will need to be shielded. People will have to live underground. They have to get a meter of regolith between you and space. And until you do, then you are at risk of damage from solar flares. Thomas Tarkey, if Plato successfully identifies a few Earth 2.0 candidates, do you think that this would inspire governments to increase astronomy funding? Probably not. I'm always so sad about the Kepler mission because it was so ambitious. This was the telescope that was going to stare at a very small piece of the sky long enough for 3 years to detect a bunch of Earth-sized worlds orbiting around sun-like stars in the habitable zone of their star. And here we are years later, almost decades later, and we still don't have an answer to that question. We could have, like if Kepler hadn't lost its reaction wheels, we could have gotten an answer to that question. Plato is our next best hope. But it's not as powerful a telescope as Kepler was. But it is expected to find a couple of Earth-sized worlds orbiting around sun-like stars in the habitable zone. The extremely large telescope should be able to observe planets like that directly orbiting around other stars. So there are tools that are coming that should give us an answer to this question. If all else fails, then we have to wait for the Habitable Worlds Observatory. But that's going to be in the 2040s? Late 2030s, 2040s. Unfortunately, we are still a long way away from finding out. Now, good news, I'm doing an interview with the designer of the Habitable Worlds Observatory in a couple of days. And so I will talk all about what it's going to take for us to be able to find that Earth 2.0. And so that's like the first part, is like, what will it take scientifically for us to be able to find that out? But the response will be what the response always is, which is that some nations invest in science, other nations don't. No matter how interesting the discoveries are, they're not usable in our day-to-day lives. And so there's like just a set amount that nations are able to afford for basic research. And so even if you do find planets orbiting around other stars like our sun in the habitable zone, it'll still just be business as usual. There will be funding, people will do research, we will learn more things, and it'll just keep going on forever and ever and ever. Ragetail, when they say the farthest galaxy we can see is 13 billion light years away and say this basically right after the Big Bang, what would Earth 4 billion years ago have seen there? The important thing to think about here is that when you see the cosmic microwave background radiation, which is like the first light that could reach out into space, and you are seeing the light as it left that place 13.8 billion years ago, that is a snapshot in time of this one region of the universe, this sort of shell around us. And the light was released, has been traveling for 13.8 billion years, and the universe has been expanding, and the light has finally reached your eyes. You know, you see the light in one direction, you see the light in the other direction, that light is getting to you at this point. And so if you were on Earth 4 billion years ago, then your cosmic microwave background radiation would be 9.8 billion years of time, that you would be seeing stuff that was 9.8 billion years ago. And it would be different stuff. Like it would be a different part of the universe, because that this sort of sphere of light that is being emitted towards you has gotten bigger. And so 4 billion years ago, the universe is much smaller, and you're seeing stuff that the light has only been traveling for just shy of 10 billion years. And it's different places, different galaxies, different spots in the sky, totally different. Now it looks kind of the same. You're seeing kind of blobs of over and under density in the cosmic microwave background radiation, but it is totally different places in the universe than what we're seeing today. And even like every second that goes by, you are seeing a different part of the universe. So think about like the size of a galaxy, right? The Milky Way is 100,000 light years across. And so that if you waited 100,000 years, you would see a galaxy's worth of width of new space out there. And you'd be seeing stuff, you know, if at the beginning, if there actually was a Milky Way galaxy, which there wouldn't be, right? Because it's early on in the universe. But if there was, then at the beginning of 100,000 years, you'd see the front end of the light from the galaxy hitting you. And then 100,000 years later, you would see the light from the back end of the galaxy finally reaching your eyes. But that analogy doesn't hold. I need a better analogy, because that one doesn't work, because, you know, there weren't galaxies back then. There was just clouds of hot hydrogen. It's time to shout out all the new $5 patrons and above. El Daka, Hal Adis, Pig, Evan Beecher, Rich B, Chunky Fuzzy Wawa, Paul L. Hayden, Mark Baines, Thomas Smith, and Jim Pizarris. Join the club at patreon.com/universe today. Mike Khalil. I always wondered how light from 13.8 billion years ago reached us now. How did we get here before the light reached us? So the thing that's really important to understand is that the observable universe that we see, the sphere of light that is around us, where the light has taken that 13.8 billion years to get to us, is not the actual universe. It is just a small portion of the actual universe. And so that's why you call it the observable universe. The way you can sort of think about that, you know, the way I describe it is you're walking in fog, and I've used this term before now, which is that you're walking in fog, and up close to you can see your hands, and then farther away you can sort of just barely see cars and stuff, and then farther away it's just fog. And so that is your local fogiverse, right? That the things that you could see very clearly next to you, I can't see if I'm also trapped in the fog somewhere else. I have my own different fogiverse. And so at the beginning of the universe, shortly after the Big Bang, about 380,000 years after the Big Bang, when the universe finally became transparent, photons of light started to head out into space. And they were able to make it all the way, travel for billions of years, because there was more universe. Like we may have this observable universe around us, but that is just, you know, there's much more universe around that. And so all of those photons have been just taking that journey for the 13.8 billion years to finally reach your eyeballs. And it is, and that every minute that goes by, new photons that started at the same time have finally completed their journey to reach your eyeballs. And then a minute later, a day later, a year later, the photons that began that journey that much longer, those photons have finally reached your eyeballs. One of them mind rocks. If dark energy is causing the universe to expand at an accelerating rate, what does this imply for the ultimate fate of galaxies that are currently bound by gravity? So if they're actually bound by gravity, in that if they're within about 5 million light years of each other, that is actually bound by gravity, and that those galaxies will get closer and closer together and they will merge into giant elliptical galaxies. The big spirals will spin into each other, the smaller dwarf galaxies will merge in with them, and you'll get these just big old blobs of stars. But if it's beyond about 5 million light years away, then the expansion of the universe and the acceleration of dark energy are stronger. And so those galaxies are going to be torn apart. And so you can sort of imagine at a local level, galaxies that are kind of close together are starting to clump together. But then clumps of galaxies are spreading apart from each other. And eventually they will fall over the cosmic horizon. So in just about 100 billion years from now, we would look out into the cosmos and we would not see any other galaxies easily. Their signals will always be there, but essentially all of the galaxies will fall over the cosmic horizon from our perspective. So what is the fate of them? The galaxies that are bound together by gravity will merge into this giant elliptical galaxy, and then the interactions between the stars will kick out stars one at a time. They'll just be thrown out into space. And eventually, and all of the stars will lose all their planets. So this is kind of interesting. So in about 10 billion years from now, just the gravitational interactions between the other stars in the Milky Way will pluck away all of the planets from the solar system one by one. You'll be left with just Mercury, probably. The sun and Mercury. And then Mercury will probably remain with the sun. But then Mercury will have been destroyed by the sun because of the red giant phase. So, there will probably be no stars. So anyway, in that long history, all the stars will eventually be kicked out of the galaxy. All of the planets will be kicked out of the star systems. You'll just be left with the black hole, the supermassive black hole at the heart of the Milky Way. That will be the Milky Way. And so you will end up with free floating stars that are separated by enormous distances in space, falling over the cosmic horizons from each other, and the supermassive black holes that are the final remnants of what were once galaxies. That is the ultimate fate. Did you know you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call that Q&A Plus. In this week's bonus question, would I go on a moon voyage? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. I'm going to get your advice about the upcoming Nancy Grace Rowan mission. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Kerrington, Chuck Hawkins, Commander Baylock, Dark Finga, David Gilton, and David Matz, Thrala Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Mattern, Jim Burke, Marcel Smith, Mike Marcel, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Rinkaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Team 49, Telescopes Canada, Vlad Zeppelin, Wolfgang Klotz, and Zeldabord Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So if you've been following our channel, you know that the Nancy Grace Roman telescope is going to be launching on August 30th at the earliest. And this is crazy, right? Because this is a telescope that is actually launching on budget and early. It was supposed to launch probably by 2027, but just everything has come together and they're ready to go. We should see this rocket take off in about 2 weeks. And this is a very special mission. I mean, this is a flagship mission. It's a Hubble Space Telescope class telescope, the biggest thing out there since James Webb. And so, we have done some pretty good deep dives into various telescopes, and I would just love to know what you would like to hear. Do you want me to do some interviews with people behind the mission? Do you want us to do like a deep dive on the telescope itself? Do you want us to wait and then give you here's everything that was found in the first year with Nancy Grace Roman? Why do I think you're just going to say all of it? But if there's something else that I haven't thought of, please let me know down in the comments below. All right, we'll see you next time.